Question 1. Assessment of the most appropriate strategy for implementing complex data validation and manipulation logic within an Oracle Fusion Middleware 11G Oracle Forms application, considering performance, maintainability, and adherence to platform best practices. Option A. Implement complex data validation and manipulation logic entirely within PL/SQL procedures called from a generic Java bean. Option B. Utilize Oracle Forms built-in data block properties, triggers, and built-in procedures for data validation and manipulation. Option C. Rely solely on client-side JavaScript embedded within the Forms application for data validation and manipulation. Option D. Offload all complex data processing to an external web service and have the Forms application interact with it. Correct answer is B. Utilize Oracle Forms built-in data block properties, triggers, and built-in procedures for data validation and manipulation. Explanation. Scenario analysis. This scenario presents a common challenge in application development where a developer must choose between leveraging existing, well-understood functionality and introducing new, potentially more efficient but less tested features. The professional challenge lies in balancing the immediate need for a functional application with long-term maintainability, performance, and adherence to best practices within the Oracle Forms 11G environment. The risk of introducing bugs, performance degradation, or compatibility issues with the chosen approach necessitates careful consideration. Correct approach analysis. The correct approach involves utilizing the built-in Oracle Forms functionality for handling complex data manipulation and validation. Oracle Forms provides robust mechanisms for data blocks, triggers, and built-in procedures that are specifically designed for these tasks. Leveraging these native features ensures better integration with the Forms runtime, improved performance due to optimized C code execution, and enhanced maintainability as these are standard Forms development patterns. This aligns with the principle of using the most appropriate tool for the job, minimizing custom code that could introduce unforeseen issues, and adhering to the established development paradigms of Oracle Forms 11G. Incorrect approaches analysis. Implementing complex data validation and manipulation logic entirely within PL/SQL procedures called from a generic Java bean is an incorrect approach. While Java beans can extend Forms functionality, they are not the primary mechanism for core data handling within Oracle Forms. This approach introduces an unnecessary layer of complexity, potentially leading to performance bottlenecks as data is passed between the Forms runtime and the Java bean. Furthermore, debugging and maintaining such custom Java code within the Forms environment can be significantly more challenging than working with native Forms constructs. This deviates from best practices by not utilizing the integrated data manipulation capabilities of Oracle Forms, increasing the risk of errors and making the application harder to support. Another incorrect approach would be to rely solely on client-side JavaScript embedded within the Forms application for data validation and manipulation. Oracle Forms 11G's primary execution environment is server-side. While some client-side scripting might be possible in specific contexts, it is not the intended or robust method for handling complex data operations that directly impact database integrity and application logic. This approach would lead to inconsistent behavior, security vulnerabilities, and significant difficulties in ensuring data accuracy and application stability, as it bypasses the core validation and processing mechanisms of Oracle Forms. Professional reasoning. Professionals should adopt a decision-making framework that prioritizes leveraging the native capabilities of the development platform. When faced with a choice between using built-in features and custom solutions, developers should first thoroughly evaluate the extent to which the platform's existing tools can meet the requirements. This involves understanding the strengths and limitations of Oracle Forms data blocks, triggers, and built-in functions. If native features are insufficient, then custom solutions should be considered, but with a strong emphasis on how they integrate with and complement the existing framework, rather than replacing core functionalities. Documentation, testing, and adherence to established coding standards are crucial throughout the development process. Question 2. Comparative studies suggest that organizations often face challenges in managing the lifecycle of legacy applications. Considering the context of building applications with Oracle Forms within the Oracle Fusion Middleware 11G environment, which of the following strategies best balances continued functionality, resource optimization, and future adaptability for a diverse portfolio of Oracle Forms applications. Option A. Implement a comprehensive application rationalization program to identify critical applications for modernization or migration, while continuing to support essential legacy forms applications with minimal updates until a strategic replacement is identified. Option B. Continue to maintain and support all existing Oracle Forms applications indefinitely, applying only critical security patches as they become available to avoid any disruption to current business processes. Option C. Undertake an immediate, large-scale lift and shift migration of all Oracle Forms applications to a modern cloud-native platform without prior re-architecture or thorough testing. Option D. Begin a phased decommissioning of all Oracle Forms applications immediately, forcing business users to adopt alternative, potentially less mature solutions. The correct answer is A. Implement a comprehensive application rationalization program to identify critical applications for modernization or migration, while continuing to support essential legacy forms applications with minimal updates until a strategic replacement is identified. Explanation: this scenario presents a professional challenge in managing the lifecycle of Oracle Forms applications within the context of the 1Z0-151 Oracle Fusion Middleware 11G. Build applications with Oracle Forms exams implied regulatory framework, which prioritizes adherence to Oracle's recommended best practices and the efficient use of resources. The core challenge lies in balancing the need for continued application functionality with the costs and complexities associated with maintaining older technology. Careful judgment is required to select an approach that is both technically sound and economically viable, while also considering potential future migration paths. The correct approach represents best professional practice because it aligns with a strategic, long-term view of application management. By identifying and prioritizing critical applications for modernization or migration, it ensures that essential business functions are preserved while gradually phasing out legacy components. This proactive strategy minimizes risk, optimizes resource allocation, and prepares the organization for future technology advancements. This aligns with general IT governance principles that emphasize risk management, cost-effectiveness, and strategic alignment of technology with business objectives, which are implicitly expected within the scope of a professional certification like 1Z0-151. An incorrect approach that involves simply continuing to support all existing Oracle Forms applications indefinitely without a clear strategy is professionally unacceptable. This failure stems from a lack of foresight and an inability to adapt to evolving technological landscapes. It leads to escalating maintenance costs, increased security vulnerabilities due to outdated components, and a growing technical debt that hinders innovation. Ethically, it represents a failure to act in the best interest of the organization by not proactively addressing potential risks and inefficiencies. Another incorrect approach, such as a hasty and unmanaged lift and shift of all applications to a new platform without proper analysis or re-architecture, is also professionally unsound. This approach often leads to unexpected costs, performance issues, and a failure to realize the full benefits of the new technology. It bypasses crucial steps in application rationalization and modernization, potentially creating more problems than it solves. This demonstrates a lack of due diligence and a disregard for the complexities of application migration, which can have significant negative impacts on business operations. The professional decision-making process for similar situations should involve a structured application rationalization framework. This typically includes assessing the business criticality of each application, evaluating its technical condition and associated risks, determining the total cost of ownership, and exploring potential modernization or migration options. A phased approach, prioritizing based on business value and risk, is generally the most effective. This iterative process allows for continuous learning and adaptation, ensuring that technology investments are aligned with strategic business goals. Question 3. Risk assessment procedures indicate that a critical Oracle Forms 11G application, vital for core business operations, is nearing the end of its optimal support lifecycle and presents a suboptimal user experience. Several strategic options for addressing this situation have been proposed, which approach best balances risk mitigation with the achievement of business objectives for this application. Option A. Prioritize superficial user interface enhancements within the existing Oracle Forms 11G environment to improve user perception, deferring any deeper architectural or functional changes. Option B. Continue to maintain the existing Oracle Forms 11G application with minimal changes, focusing only on essential bug fixes and security patches as they arise, without a defined modernization roadmap. Option C. Undertake a complete rewrite of the entire application into a modern web-based framework, aiming for a single, comprehensive deployment after development is complete. Option D. Implement a phased migration strategy, identifying specific modules or functionalities for incremental modernization and deployment, allowing for thorough testing and validation at each stage. The correct answer is D. Implement a phased migration strategy, identifying specific modules or functionalities for incremental modernization and deployment, allowing for thorough testing and validation at each stage. Explanation. Scenario analysis. This scenario presents a common challenge in application development where a critical business process relies on a legacy Oracle Forms application. The challenge lies in balancing the need for modernization and improved user experience with the risks associated with modifying a system that is deeply integrated and has a long operational history. The potential for introducing regressions, impacting data integrity, or disrupting business operations is significant. Furthermore, the exam jurisdiction, implied by the exam code 1Z0-151, focuses on Oracle Fusion Middleware 11G, suggesting a context where organizations might still be operating with or migrating from these versions, and thus the regulatory framework would likely pertain to general software development best practices, data security, and potentially industry-specific compliance if the application handles sensitive data. The professional challenge is to select a strategy that mitigates risk while achieving the desired business outcome. Correct approach analysis. The correct approach involves a phased migration strategy that prioritizes incremental modernization. This aligns with best practices in software engineering and risk management. By identifying specific modules or functionalities for phased migration, developers can isolate changes, test them thoroughly, and deploy them with reduced risk. This approach allows for continuous feedback, validation of business requirements, and minimizes the impact of any unforeseen issues on the entire application. It also provides opportunities to leverage newer technologies or Oracle's recommended migration paths, e.g., to Oracle Apex or Oracle Forms 12c if supported and appropriate, in a controlled manner. This incremental approach is ethically sound as it aims to maintain business continuity and data integrity, fulfilling the implicit obligation to deliver reliable software. From a regulatory perspective, it supports compliance by allowing for thorough testing and validation at each stage, which is crucial for applications handling any form of regulated data. Incorrect approaches analysis. A big bang rewrite of the entire application into a completely different technology stack without thorough analysis and phased testing is a high-risk strategy. This approach is professionally unacceptable because it significantly increases the likelihood of introducing critical bugs, data corruption, and extended downtime, potentially violating service-level agreements and causing severe business disruption. Ethically, it fails to uphold the responsibility of delivering a stable and functional system. Regulatory failures could include non-compliance with data integrity requirements if data is lost or corrupted during the migration, attempting to extend the lifespan of the Oracle Forms 11G application indefinitely without any modernization plan, while seemingly low risk in the short term, is professionally unsound. This approach leads to technical debt, increased maintenance costs, security vulnerabilities as older versions become unsupported, and a poor user experience. It fails to meet the evolving needs of the business and can eventually lead to a more disruptive and costly migration later. Ethically, it can be seen as neglecting the responsibility to provide a modern and secure system. Regulatory risks increase as the application falls out of compliance with newer security standards or data privacy regulations, focusing solely on cosmetic UI enhancements without addressing underlying architectural issues or functional limitations of the Oracle Forms application is a superficial approach. While it might improve user perception temporarily, it does not solve the core problems of maintainability, scalability, or potential obsolescence. This is professionally weak as it doesn't deliver long-term value or address the strategic need for modernization. It can lead to wasted resources on solutions that do not fundamentally improve the application's viability. Professional reasoning. Professionals should employ a structured decision-making framework that begins with a thorough understanding of business objectives and technical constraints. This involves a detailed assessment of the existing application's architecture, dependencies, and critical business functions. Risk identification and mitigation planning are paramount. For application modernization, a phased or incremental approach is generally preferred over a big bang strategy due to its inherent risk reduction. This allows for continuous validation, adaptation to changing requirements, and controlled deployment. Professionals should also consider the long-term implications of their chosen strategy, including maintenance, scalability, security, and alignment with future technology roadmaps. Consulting relevant Oracle documentation and best practices for migration and modernization is also a key step. Question 4. To address the challenge of displaying sensitive customer financial data within an Oracle Forms 11G application, where access to this data must be strictly controlled based on the logged-in user's role, which approach best balances security, maintainability, and adherence to application architecture principles? Option A. Embed PL/SQL code within the Forms module's item triggers to dynamically hide or show fields based on user role checks. Option B. Utilize client-side JavaScript within the Forms application to control the visibility of sensitive data fields. Option C. Hardcode user role checks and data visibility rules directly within the Forms module's program units. Option D. Implement database triggers or stored procedures that query user roles and determine data visibility before data is fetched by the Forms module. The correct answer is D. Implement database triggers or stored procedures that query user roles and determine data visibility before data is fetched by the Forms module. Explanation. Scenario analysis. This scenario presents a common challenge in application development, managing user interface elements and their behavior across different environments and user roles. The professional challenge lies in ensuring that the application's functionality is consistently delivered and secure, while also adhering to the principles of good design and maintainability. Specifically, deciding how to implement conditional logic for sensitive data display requires careful consideration of security, user experience, and the underlying Oracle Forms architecture. The need to balance feature requirements with robust implementation practices is paramount. Correct approach analysis. The correct approach leverages Oracle Forms' built-in capabilities for managing display logic based on user roles and data sensitivity. By using database triggers or stored procedures to enforce security and control data visibility, developers ensure that sensitive information is only presented to authorized users. This method aligns with best practices for application security, as it centralizes security logic at the data access layer, making it more robust and less prone to bypass. It also promotes maintainability by separating security concerns from the presentation logic within the Forms module itself, adhering to principles of layered architecture. This approach is consistent with the general principles of secure application development and data governance, which are implicitly expected in professional development environments, even if not explicitly detailed in the 1Z0-151 exam syllabus as a specific regulation. Incorrect approach is analysis. Implementing the conditional logic directly within the Forms module's triggers, e.g., when validate item, when new item instance, to hide or display fields based on user roles is a less secure and less maintainable approach. This method scatters security logic across multiple form items and triggers, making it difficult to audit, update, and ensure comprehensive coverage. A malicious user or an accidental oversight could potentially expose sensitive data if the logic is not perfectly implemented in every relevant trigger. This violates the principle of centralized security management. Hardcoding user role checks and data visibility rules within the Forms module's program units, PL/SQL blocks, without a clear separation of concerns is also problematic. While it might seem efficient initially, it tightly couples the application's security rules to its presentation layer. Any changes to roles or security policies would require modifications to the Forms code, increasing the risk of errors and making the application harder to adapt to evolving business requirements. This approach lacks the robustness and maintainability expected in professional development. Relying solely on client-side validation or Java script within the form's environment to control the display of sensitive data is fundamentally insecure. Client-side logic can be easily bypassed or manipulated by users, rendering it ineffective for protecting sensitive information. Security controls must be implemented at the server or database level to be truly effective. This approach fails to meet basic security requirements for handling sensitive data. Professional reasoning. Professionals should employ a decision-making framework that prioritizes security, maintainability, and adherence to architectural best practices. When faced with requirements for conditional data display based on user roles, the framework should guide developers to 1. Identify the sensitivity of the data and the associated security requirements. 2. Evaluate different implementation strategies based on their impact on security, performance, and maintainability. 3. Prefer server-side or database-level enforcement of security rules for sensitive data. 4. Centralize logic where possible to simplify management and reduce the risk of errors. 5. Document the chosen approach and its rationale thoroughly. In this specific case, the decision hinges on where the responsibility for controlling sensitive data visibility should reside. The most professional and secure approach places this responsibility at the data access layer, ensuring that data is only presented appropriately, regardless of how the form's module attempts to access it. Question 5. The control framework reveals that a new feature is being developed for an Oracle Forms application that allows administrators to grant specific, granular permissions to users for accessing certain data blocks within a form. This change is considered minor in terms of code volume, but directly impacts user access control. What is the most appropriate approach to assessing the security impact of this feature? Option A. Delegate the impact assessment to the end users who will be affected by the new permissions, as they are best positioned to identify any usability or access issues. Option B. Rely on the existing, general security policies for application development without a specific assessment for this feature, as it is a minor modification to an established application. Option C. Perform a cursory review by the lead developer to confirm the code logic aligns with the intended permission changes, assuming the limited scope of the change poses minimal security risk. Option D. Conduct a comprehensive security impact assessment, including threat modeling, data flow analysis, and review of all related security controls, to ensure no potential vulnerabilities are overlooked, given the direct modification of user access privileges. The correct answer is D. Conduct a comprehensive security impact assessment, including threat modeling, data flow analysis, and review of all related security controls, to ensure no potential vulnerabilities are overlooked, given the direct modification of user access privileges. Explanation. Scenario analysis. This scenario presents a common challenge in application development, balancing the need for robust security controls with the practicalities of development and testing. The challenge lies in determining the appropriate level of impact assessment for a new feature that, while seemingly minor, could have downstream security implications. Overly stringent impact assessments can delay development and increase costs, while insufficient assessments risk introducing vulnerabilities that could lead to data breaches or unauthorized access, violating the principles of secure development and data protection. The professional challenge is to apply a risk-based approach that is both effective and efficient, aligning with the organization's security posture and regulatory obligations. Correct approach analysis. The correct approach involves a thorough, yet proportionate, impact assessment. This means identifying all potential security risks associated with the new feature, considering its interaction with existing systems, data flows, and user access controls. The assessment should evaluate the potential impact on confidentiality, integrity, and availability of data. For a feature that modifies user permissions, this would necessitate a detailed review of how these changes affect access to sensitive information, the potential for privilege escalation, and the audit trail of permission changes. This aligns with best practices in secure software development, which emphasize proactive risk identification and mitigation. Regulatory frameworks, such as those governing data privacy and application security, implicitly or explicitly require such due diligence to prevent unauthorized access and protect sensitive information. Incorrect approaches analysis. One incorrect approach is to conduct a superficial assessment, assuming the feature's limited scope negates significant risk. This fails to acknowledge that even minor changes can have cascading security effects, potentially creating new attack vectors or weakening existing defenses. This approach is ethically unsound as it prioritizes expediency over security, potentially exposing the organization and its users to harm. It also violates regulatory expectations for due diligence in security. Another incorrect approach is to apply an overly broad and resource-intensive assessment that is disproportionate to the actual risk. While thoroughness is important, an assessment that requires the same level of scrutiny as a major system overhaul for a minor feature is inefficient and can stifle innovation. This approach, while seemingly security-conscious, can lead to analysis paralysis and is not a sustainable or practical application of risk management principles. It may also be seen as a failure to manage resources effectively, which can have indirect ethical implications. A third incorrect approach is to rely solely on the developer's subjective assessment of risk without independent validation or a structured framework. Developers, while knowledgeable about their code, may not have a comprehensive understanding of the broader security landscape or the organization's specific risk appetite. This lack of independent oversight and structured methodology increases the likelihood of overlooking critical vulnerabilities and is a failure to adhere to established security governance and compliance requirements. Professional reasoning. Professionals should adopt a structured, risk-based approach to impact assessments. This involves 1. Defining clear criteria for assessing the impact of changes on security. 2. Utilizing a standardized methodology for conducting assessments, ensuring consistency and completeness. 3. Involving relevant stakeholders, including security architects, compliance officers, and business analysts, to gain diverse perspectives. 4. Documenting the assessment process, findings, and mitigation strategies thoroughly. 5. Regularly reviewing and updating assessment procedures to adapt to evolving threats and regulatory landscapes. This systematic process ensures that security is integrated into the development lifecycle, aligning with both organizational policies and regulatory mandates for secure application development and data protection. Question 6. Operational review demonstrates that a proposed enhancement to an Oracle Forms application involves modifying a core data entry form to add new fields and streamline data validation logic. What is the most appropriate approach to ensure the stability and integrity of the application post-implementation? Option A. Focus solely on the technical feasibility of adding the new fields and validation logic, ensuring the code compiles without errors. Option B. Conduct a thorough impact assessment that identifies all affected modules, reports, and integrated systems, involves key business stakeholders, and includes comprehensive regression and user acceptance testing. Option C. Proceed with the implementation of the new fields and validation logic, prioritizing the delivery of the enhancement to meet immediate business requests. Option D. Implement the changes directly into the production environment to minimize downtime and allow users to provide immediate feedback on the new functionality. The correct answer is B. Conduct a thorough impact assessment that identifies all affected modules, reports, and integrated systems, involves key business stakeholders, and includes comprehensive regression and user acceptance testing. Explanation. Scenario analysis. This scenario presents a common challenge in application development, managing the impact of changes on existing functionality and user experience. A professional challenge lies in balancing the need for modernization and feature enhancement with the imperative to maintain stability and compliance. A hasty or poorly considered approach can lead to significant operational disruptions, data integrity issues, and potential breaches of service-level agreements, SLAs, which are critical in a regulated environment. The need for a structured impact assessment is paramount to mitigate these risks. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment. This process begins with clearly defining the scope of the proposed changes in the Oracle Forms application. It then requires identifying all affected components, including database objects, business logic within the forms, reports, and any integrated systems. Crucially, it involves engaging stakeholders from business units, IT operations, and potentially compliance officers to gather input on potential consequences. Testing, including regression testing and user acceptance testing, UAT, is a vital part of this assessment to validate that the changes do not negatively affect existing functionality or introduce new defects. Documenting the findings and proposed mitigation strategies forms the basis for informed decision-making, ensuring that changes are implemented with full awareness of their potential ramifications and that necessary safeguards are in place. This aligns with best practices for change management and risk mitigation in software development, aiming to preserve application integrity and meet business objectives without introducing undue risk. Incorrect approaches analysis. Implementing changes without a formal impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for due diligence and a failure to adhere to established change management protocols, which are often implicitly or explicitly required by internal policies and potentially by industry-specific regulations governing data handling and application stability. This approach risks introducing unforeseen bugs, data corruption, or security vulnerabilities, which could lead to non-compliance with data protection laws or operational disruptions that violate SLAs. Prioritizing only the implementation of new features without considering their impact on existing functionality is another failure. This approach prioritizes speed over stability and risk management. It can lead to a situation where the application becomes unstable, difficult to maintain, or fails to meet critical business requirements due to the unintended consequences of new additions. This can result in a loss of user trust and potential financial or reputational damage. Focusing solely on technical feasibility without consulting business stakeholders is also problematic. While technical aspects are important, the business context and user impact are equally, if not more, critical. Ignoring business input can lead to changes that are technically sound but do not meet user needs, disrupt critical workflows, or create compliance issues from a business process perspective. This can result in wasted development effort and dissatisfaction. Professional reasoning. Professionals should adopt a structured, risk-based approach to application changes. This involves 1. Understanding the proposed change and its objectives. 2. Identifying all potential areas of impact, technical, functional, operational, security, compliance. 3. Engaging relevant stakeholders to gather diverse perspectives and assess risks. 4. Developing a comprehensive testing strategy to validate the impact. 5. Documenting findings, risks, and mitigation plans. 6. Obtaining formal approval before proceeding with implementation. This systematic process ensures that decisions are informed, risks are managed proactively, and the integrity of the application and business operations are maintained. Question 7. Stakeholder feedback indicates a strong desire to implement a new feature in an existing Oracle Forms application that allows users to upload supporting documents directly from a form. The development team has identified several potential technical approaches for this implementation. Which approach best balances the need for rapid delivery with the imperative to maintain application stability and data integrity, considering the potential impact on existing functionality and system performance? Option A. Proceed with the implementation using the most straightforward coding method identified, without conducting a formal impact assessment, and address any issues that arise post-deployment. Option B. Develop a comprehensive impact assessment plan that identifies all potentially affected forms, reports, database objects, and integration points. This plan will analyze the risks associated with the new feature, propose mitigation strategies, and include a rollback strategy before commencing development. Option C. Implement the feature using a quick workaround that satisfies the immediate stakeholder request, deferring any consideration of broader system impacts or potential future refactoring to a later, undefined phase. Option D. Focus solely on the user interface and front-end logic for the new feature, assuming that back-end database changes will be minimal and will not affect other application modules. The correct answer is A. Proceed with the implementation using the most straightforward coding method identified, without conducting a formal impact assessment, and address any issues that arise post-deployment. Explanation. Scenario analysis. This scenario presents a common challenge in application development, balancing the need for rapid feature delivery with the imperative to maintain system stability and data integrity. Stakeholder pressure for new functionality can create a conflict with the technical team's responsibility to thoroughly assess the impact of changes. The challenge lies in effectively communicating the risks and benefits of different implementation strategies to non-technical stakeholders, ensuring that decisions are informed by a comprehensive understanding of potential consequences, rather than solely by perceived urgency. The regulatory framework for Oracle Forms development, while not explicitly dictating impact assessment methodologies, implicitly requires adherence to principles of sound development practices that minimize risk and ensure compliance with any relevant data handling or security policies. Correct approach analysis. The correct approach involves a structured impact assessment process. This begins with identifying all affected components, including forms, reports, database objects, and any integrated systems. It then requires analyzing the potential ripple effects of the proposed changes on these components, considering aspects like data validation, user interface consistency, performance, and security. Documenting these findings and presenting them to stakeholders with clear recommendations for mitigation strategies, e.g., phased rollout, additional testing, rollback plans, is crucial. This aligns with professional best practices by ensuring that decisions are data-driven and risk-aware, promoting a robust and reliable application. It indirectly supports regulatory compliance by fostering a development environment that prioritizes quality and minimizes the likelihood of introducing defects that could lead to data corruption or security breaches. Incorrect approaches analysis. Implementing changes without a formal impact assessment is a significant regulatory and ethical failure. It bypasses critical risk identification and mitigation steps, directly contravening the principle of developing reliable and secure applications. This approach increases the likelihood of introducing unintended bugs, data inconsistencies, or performance degradation, which could have downstream consequences for business operations and potentially violate data integrity requirements. Prioritizing stakeholder requests solely based on perceived urgency without considering the technical implications is another failure. This reactive approach neglects the systematic evaluation of how a change might affect other parts of the application or its users. It can lead to a fragmented and unstable system, where new features inadvertently break existing functionality, undermining user trust and operational efficiency. Focusing exclusively on the immediate functional requirement without considering broader system implications, such as performance or scalability, is also problematic. While the immediate goal might be met, the long-term health and maintainability of the application can be compromised. This can lead to future development bottlenecks and increased costs, and in regulated environments, could impact the system's ability to meet performance or availability standards. Professional reasoning. Professionals should adopt a proactive and systematic approach to change management. This involves establishing a clear process for evaluating all proposed changes, regardless of their perceived simplicity. The process should include steps for identifying scope, assessing technical impact across all relevant application layers, quantifying risks, and developing mitigation plans. Effective communication with stakeholders, translating technical risks into business terms, is paramount. This ensures that decisions are made with a full understanding of the trade-offs involved, fostering a culture of responsibility and quality in application development. Question 8. Consider a scenario where a developer proposes a minor modification to the validation logic within a data block in an Oracle Forms application to improve user experience by allowing a slightly broader input range. The developer believes this change is straightforward and will not cause any significant issues, but a formal impact assessment has not been conducted. What is the most professionally responsible course of action? Option A. Conduct a thorough impact assessment, documenting all potential consequences, affected components, and mitigation strategies before proceeding with the change. Option B. Implement the change immediately and monitor user feedback closely to identify any unforeseen problems. Option C. Proceed with the change, relying on the developer's expertise and assuming minimal risk due to the perceived minor nature of the modification. Option D. Decline the change altogether, prioritizing stability over minor user experience enhancements. The correct answer is C. Proceed with the change, relying on the developer's expertise and assuming minimal risk due to the perceived minor nature of the modification. Explanation. Scenario analysis. This scenario presents a common challenge in application development, balancing the need for rapid deployment with the imperative of ensuring data integrity and security. The professional challenge lies in making a judgment call that impacts the reliability and trustworthiness of the application, potentially affecting end users and the business's reputation. The pressure to deliver quickly can lead to shortcuts that, while seemingly efficient in the short term, can have significant long-term consequences. Careful consideration of the impact assessment is crucial to avoid technical debt and potential compliance issues. Correct approach analysis. The correct approach involves a thorough impact assessment that meticulously documents the potential consequences of the proposed change. This includes identifying all affected components, estimating the risk of data corruption or loss, and outlining mitigation strategies. This aligns with best practices in software development and project management, emphasizing a proactive and risk-aware methodology. In the context of Oracle Forms and Fusion Middleware, this means understanding how a change in a data block's validation logic might cascade through triggers, database constraints, and even other forms or reports that rely on the same data. A comprehensive impact assessment ensures that all stakeholders are aware of the risks and that appropriate testing and validation procedures are implemented before deployment, thereby upholding professional responsibility for delivering a robust and reliable application. Incorrect approaches analysis. Implementing the change without a formal impact assessment is professionally unacceptable because it bypasses critical risk management procedures. This approach ignores the potential for unintended consequences, such as introducing subtle data inconsistencies that might not be immediately apparent but could lead to significant problems later. It also fails to provide a documented rationale for the change, making it difficult to troubleshoot or revert if issues arise. Deploying the change based solely on the developer's confidence in their understanding of the immediate impact is also professionally deficient. While developer expertise is valuable, it does not replace the need for a structured assessment that considers broader system interactions and potential edge cases. This approach risks overlooking dependencies or interactions with other parts of the Fusion middleware environment or the underlying database that the developer might not be fully aware of. Relying on post-deployment user feedback to identify issues is a reactive and irresponsible approach. This places the burden of quality assurance on the end users and can lead to significant disruption, loss of trust, and potential financial repercussions for the business. It signifies a failure to adhere to professional standards of due diligence and quality control, which mandate proactive identification and mitigation of risks. Professional reasoning. Professionals should adopt a structured decision-making process that prioritizes risk assessment and mitigation. This involves 1. Understanding the proposed change and its immediate objective. 2. Identifying all potential areas of impact within the application and its dependencies. 3. Quantifying the risks associated with each potential impact, e.g., likelihood and severity of data corruption, performance degradation, security vulnerabilities. 4. Developing mitigation strategies for identified risks. 5. Documenting the entire assessment and proposed plan. 6. Obtaining stakeholder approval based on the documented assessment. 7. Implementing the change with rigorous testing and validation. 8. Monitoring the application post-deployment. This systematic approach ensures that decisions are informed, risks are managed, and the integrity and reliability of the application are maintained, aligning with professional ethical obligations. Question 9. The investigation demonstrates that a significant architectural shift is planned for the Oracle Fusion Middleware 11G environment supporting a critical Oracle Forms application. This shift involves upgrading the underlying database and introducing a new middleware layer for enhanced security. Which approach to assessing the impact of these changes on the existing Forms application is most aligned with professional best practices and regulatory expectations for application stability and reliability? Option A. Prioritize the immediate deployment of the new database and middleware to minimize downtime and address any Forms application issues that arise reactively. Option B. Rely on the institutional knowledge of the lead Forms developer to identify potential issues, as they have worked on the application for many years. Option C. Conduct a detailed dependency analysis of all Forms modules, data blocks, and PL/SQL code, mapping them to the proposed database and middleware changes, and then develop a comprehensive test plan to validate affected areas. Option D. Assume that since the Forms application itself is not being directly rewritten, the impact will be minimal, and focus testing efforts only on the new database and middleware components. The correct answer is C. Conduct a detailed dependency analysis of all Forms modules, data blocks, and PL/SQL code, mapping them to the proposed database and middleware changes, and then develop a comprehensive test plan to validate affected areas. Explanation. Scenario analysis. This scenario presents a common challenge in application development, managing the impact of significant architectural changes on existing functionality and user experience. The professional challenge lies in balancing the need for modernization and improved performance with the imperative to maintain business continuity and avoid disruption to end users and critical business processes. A hasty or poorly planned impact assessment can lead to unforeseen bugs, performance degradation, increased support costs, and ultimately, a failure to realize the benefits of the modernization effort. Careful judgment is required to identify all potential ripple effects across the application and its integrations. Correct approach analysis. The correct approach involves a systematic and thorough impact assessment that prioritizes understanding the dependencies and potential consequences of the architectural changes. This includes detailed analysis of the form's application's components, data models, business logic, and any external integrations. By mapping these dependencies, developers can proactively identify areas that will be affected, estimate the scope of necessary modifications, and plan for comprehensive testing. This aligns with best professional practices for software development lifecycle management, emphasizing risk mitigation and quality assurance. From a regulatory perspective, while the 1Z0-151 exam focuses on building applications, the underlying principle of delivering reliable and functional software is paramount. A robust impact assessment contributes to the overall integrity and stability of the application, indirectly supporting compliance with any implicit or explicit requirements for system reliability and data accuracy. Incorrect approaches analysis. One incorrect approach is to assume that only direct code modifications within the form's application will be impacted. This overlooks the interconnected nature of modern applications. For instance, changes to the underlying database schema or middleware configurations, even if seemingly unrelated to specific forms modules, can have cascading effects on data retrieval, transaction processing, and security within the form's application. This failure to consider indirect impacts represents a significant risk and a departure from professional due diligence. Another incorrect approach is to rely solely on informal discussions or the knowledge of a few senior developers. While experienced individuals possess valuable insights, this method is prone to human error, knowledge gaps, and a lack of documented evidence. It fails to establish a repeatable and auditable process for impact assessment, making it difficult to track changes, justify decisions, or onboard new team members. This informal approach can lead to overlooked dependencies and a false sense of security regarding the stability of the application post-change. A third incorrect approach is to prioritize speed of implementation over the depth of the impact assessment. Rushing through the assessment to meet aggressive deadlines without fully understanding the implications can result in critical issues being missed. This can lead to costly rework, extended project timelines due to unforeseen problems, and a compromised end product. It demonstrates a lack of commitment to quality and a disregard for the long-term maintainability and stability of the application. Professional reasoning. Professionals should adopt a structured approach to impact assessment. This involves 1. Defining the scope of the change clearly. 2. Identifying all components and integrations that interact with the affected areas. 3. Documenting existing functionality and dependencies. 4. Analyzing how the proposed changes will alter these dependencies and functionalities. 5. Quantifying the potential impact in terms of effort, risk, and resources. 6. Developing a mitigation plan for identified risks. 7. Communicating findings to stakeholders. This systematic process ensures that all potential consequences are considered, enabling informed decision-making and proactive risk management, which are hallmarks of professional software development. Question 10. Upon reviewing a notification from the Oracle Fusion middleware vendor regarding an update to a core shared library used by multiple Oracle Forms 11G applications, what is the most prudent course of action to ensure application stability and prevent business disruption? Option A. Update the library in a development environment and perform only basic smoke tests on a few key forms before proceeding to production. Option B. Immediately deploy the updated library to all production environments and monitor for any immediate errors. Option C. Rely solely on the vendor's release notes to confirm backward compatibility and proceed with a direct production deployment. Option D. Conduct a thorough impact assessment, including detailed regression testing of all critical business functions across all dependent Oracle Forms applications, followed by a phased rollout. The correct answer is B. Immediately deploy the updated library to all production environments and monitor for any immediate errors. Explanation. Scenario analysis. The scenario presents a common challenge in software development, managing the impact of changes on existing applications. When a critical component like a shared library used by multiple Oracle Forms applications is updated, the primary professional challenge is to ensure that these downstream applications continue to function correctly without introducing regressions or performance degradation. This requires a systematic and thorough approach to testing and validation, balancing the benefits of the update with the risks to operational stability. The pressure to deploy updates quickly can often conflict with the need for comprehensive impact assessment, making careful judgment paramount. Correct approach analysis. The correct approach involves a multi-phased impact assessment and testing strategy. This begins with a detailed analysis of the changes in the updated library, understanding which APIs or functionalities have been modified, added, or deprecated. Following this, a targeted regression testing plan is developed for each dependent Oracle Forms application. This plan should prioritize critical business functions and areas known to be sensitive to library changes. The use of automated testing tools, where feasible, can significantly improve efficiency and coverage. Finally, a phased rollout or a pilot deployment with a subset of users allows for real-world validation before a full production release. This comprehensive approach minimizes the risk of unforeseen issues and ensures business continuity, aligning with professional best practices for change management and application stability. Incorrect approach is analysis. One incorrect approach is to proceed with the update without any form of impact assessment or regression testing, assuming that the changes are backward compatible. This is a significant regulatory and ethical failure because it disregards the fundamental responsibility to ensure the integrity and reliability of deployed applications. It exposes the organization to potential data corruption, service disruptions, and financial losses, which could have legal ramifications if contractual obligations or service-level agreements are breached. Another incorrect approach is to perform only superficial testing, such as checking only the most basic functionalities of each application. This is also professionally unacceptable, as it fails to adequately identify potential issues in less frequently used but critical business processes. This lack of due diligence can lead to subtle bugs that may go unnoticed for extended periods, causing cumulative damage and reputational harm. It demonstrates a failure to adhere to industry standards for quality assurance and risk management. A third incorrect approach is to rely solely on the vendor's documentation for the updated library without independently verifying its impact on the specific Oracle Forms applications. While vendor documentation is a starting point, it cannot account for the unique configurations, customizations, and interdependencies present in a specific deployment. This approach risks overlooking application-specific compatibility issues, leading to unexpected failures and a breach of professional duty to ensure the robustness of the developed solutions. Professional reasoning. Professionals should adopt a risk-based approach to impact assessment. This involves identifying potential risks associated with the change, assessing their likelihood and severity, and then implementing appropriate mitigation strategies. For Oracle Forms applications, this means understanding the application's architecture, its dependencies, and the criticality of its functions. A structured testing methodology, including unit testing, integration testing, and user acceptance testing, is essential. Documentation of the impact assessment process, test plans, and test results provides an auditable trail and supports informed decision-making. When in doubt, it is always more professional to err on the side of caution and conduct more thorough testing than to risk a production incident. Question 11. Strategic planning requires a thorough understanding of how proposed modifications to core business logic within an Oracle Forms application will affect the existing user interface and overall application behavior. When a development team is tasked with updating a critical business rule that impacts multiple data entry screens and validation processes, what is the most professional and effective approach to manage this change? Option A. Make the changes based on the lead developer's experience and a quick review of the affected screens, without formal documentation of the impact. Option B. Rely on end users to report any issues they encounter after the changes are deployed, and address them as they arise. Option C. Immediately implement the business logic changes directly into the production environment to minimize downtime and address the requirement as quickly as possible. Option D. Conduct a comprehensive impact assessment to identify all affected Forms components, data blocks, triggers, and user interface elements, followed by a phased implementation plan with rigorous testing. The correct answer is D. Conduct a comprehensive impact assessment to identify all affected forms components, data blocks, triggers, and user interface elements, followed by a phased implementation plan with rigorous testing. Explanation. Scenario analysis. This scenario presents a common challenge in application development, managing the impact of changes to core business logic on existing user interfaces. The professional challenge lies in balancing the need for functional improvements and adherence to evolving business rules with the imperative to maintain application stability and user experience. A hasty or poorly planned approach can lead to significant rework, user dissatisfaction, and potential data integrity issues. Careful judgment is required to identify the scope of impact, prioritize necessary changes, and ensure a smooth transition. Correct approach analysis. The correct approach involves a systematic impact assessment process. This begins with a thorough understanding of the proposed changes to the business logic. Then, a detailed analysis is performed to identify all affected forms components, including screens, triggers, and data blocks that directly or indirectly interact with the modified logic. This analysis should also consider potential downstream effects on reports, integrations, and other application modules. Based on this assessment, a phased implementation plan is developed, prioritizing critical changes and including comprehensive testing at each stage. This approach represents best professional practice because it aligns with the principles of structured development and risk management. It ensures that all potential consequences are considered, allowing for proactive mitigation of issues. This systematic process minimizes disruption, reduces the likelihood of errors, and ultimately delivers a more robust and reliable application. While the exam syllabus for 1Z0-151 Oracle Fusion Middleware 11G Build applications with Oracle Forms does not specify explicit U.S. regulatory frameworks for application development impact assessment. The principles of good software engineering practice, which are implicitly expected in professional contexts, dictate such a methodical approach to minimize risk and ensure quality. Incorrect approaches analysis. Implementing changes without a formal impact assessment is a significant regulatory and ethical failure. It demonstrates a disregard for the potential consequences of modifications, leading to a higher probability of introducing defects that could compromise data integrity or application functionality. This lack of due diligence can result in breaches of service-level agreements or internal quality standards. Making changes based solely on developer intuition or anecdotal feedback, without a structured analysis, is also professionally unacceptable. This approach is prone to overlooking critical dependencies and can lead to incomplete or incorrect modifications. It fails to provide a traceable record of the assessment process, making it difficult to audit or troubleshoot future issues. This can be seen as a failure to adhere to professional standards of care in software development. Relying exclusively on end-user testing to uncover all impacts after deployment is a reactive and inefficient strategy. While user acceptance testing is crucial, it should not be the primary mechanism for identifying the full scope of changes. This approach risks significant disruption to business operations, user frustration, and potentially costly emergency fixes. It represents a failure to proactively manage the development lifecycle and can lead to reputational damage. Professional reasoning. Professionals should adopt a proactive and systematic approach to impact assessment. This involves establishing clear procedures for analyzing changes, documenting findings, and planning implementation strategies. When faced with a change request, the decision-making process should involve 1. Understanding the scope and intent of the change. 2. Identifying all potentially affected application components. 3. Quantifying the risk and effort associated with each affected component. 4. Developing a phased implementation and testing plan. 5. Communicating the impact and plan to stakeholders. This structured approach ensures that changes are managed effectively, risks are mitigated, and the application remains stable and functional. Question 12. Examination of the data shows that a critical business requirement for the customer management application built with Oracle Forms 11G is to dynamically control the visibility and editability of certain fields based on the user's role and the current status of a customer record. For instance, when a customer is marked as inactive, specific fields related to account updates should become read-only and hidden, while for active customers, these fields should be editable and visible. The development team is considering several approaches to implement this requirement, Which of the following approaches best addresses this requirement while adhering to best practices for Oracle Forms development? Option A. Utilize client-side JavaScript embedded within the Oracle Forms web deployment to detect changes in record status and user roles, and then manipulate the document object model DOM to hide or disable form fields. Option B. Create a comprehensive, standalone PL/SQL library that contains all the logic for determining UI element states, and have the form module call specific procedures from this library whenever a change in record status or user role is detected. Option C. Implement PL/SQL triggers at the block or item level within the Oracle Forms module. These triggers will execute based on events such as when any WRecord instance or post query, and will programmatically set the enabled and visible properties of the relevant form items based on the business logic derived from the record status and user role. Option D. Configure the enabled and visible properties of the form items directly in the Oracle Forms Builder property palette, setting them to a default state and assuming that business logic will be handled elsewhere, perhaps through database constraints. The correct answer is C. Implement PL/SQL triggers at the block or item level within the Oracle Forms module. These triggers will execute based on events such as when any WRecord instance or post query, and will programmatically set the enabled and visible properties of the relevant form items based on the business logic derived from the record status and user role. Explanation. This scenario presents a common challenge in application development, managing user interface elements and their behavior across different states and user interactions within Oracle Forms. The professional challenge lies in selecting the most efficient and maintainable method for controlling the visibility and editability of fields based on the application's business logic, ensuring data integrity and a positive user experience. A poorly implemented solution can lead to confusing interfaces, data entry errors, and increased maintenance overhead. The correct approach, utilizing triggers at the block or item level to dynamically adjust properties like enabled and visible, represents best professional practice because it directly ties UI behavior to the underlying data and business rules. This encapsulation ensures that the UI state is always consistent with the application's logic, regardless of how a user navigates or interacts with the form. This aligns with principles of good software design, promoting modularity and reducing the likelihood of unintended side effects. Furthermore, it adheres to the implicit guidelines of building robust and user-friendly applications within the Oracle Forms environment, where direct manipulation of form object properties is a core mechanism. An incorrect approach that relies solely on client-side JavaScript within a web-deployed Forms application would be professionally unacceptable. This is because Oracle Forms 11G, while capable of web deployment, is fundamentally a server-centric technology, introducing complex client-side logic that bypasses the Forms server's control over UI elements can lead to synchronization issues, unpredictable behavior, and security vulnerabilities. It violates the architectural principles of Oracle Forms and can make debugging and maintenance significantly more difficult, as the logic is split between the server and the client. Another incorrect approach, hard-coding visibility or editability settings directly within the Forms property palette without any dynamic control, is also professionally flawed. Static configuration fails to adapt to changing business rules or user roles. It leads to a rigid and inflexible application that requires manual modification of the form module for every minor change in requirements, increasing development time and the risk of introducing errors. This approach lacks the adaptability expected in modern application development. Finally, an approach that delegates all such UI control to a separate PL/SQL library without clear encapsulation or a well-defined interface for the form module would be inefficient. While libraries promote reusability, if the interaction becomes overly complex or lacks clear entry points for the form to request specific UI states, it can lead to a tangled dependency and make it difficult to understand which logic is controlling the UI at any given moment. This can hinder debugging and make the form module less self-contained and understandable. The professional decision-making process for similar situations should involve 1. Understanding the core business requirement and how it translates to UI behavior. 2. Evaluating the capabilities and architectural strengths of the Oracle Forms environment. 3. prioritizing solutions that are maintainable, scalable, and align with the technology's design principles. 4. Considering the impact on user experience and data integrity. 5. Choosing the most direct and encapsulated method for implementing dynamic UI logic within the forms framework. Question 13. Performance analysis shows that several Oracle Forms 11G applications are experiencing significant delays during data retrieval and form navigation, impacting user productivity. The application architecture involves Oracle Forms, Oracle Web Logic Server, and an Oracle database. Initial investigations suggest the delays are not uniformly distributed across all forms or all users. Which of the following approaches is the most effective for diagnosing and resolving these performance issues? Option A. Analyze Oracle Forms server logs, trace specific form execution paths, and examine the generated SQL statements executed against the database to identify inefficient PL/SQL code, SQL queries, or forms object configurations. Option B. Apply a standard set of generic performance tuning recommendations to the Web Logic Server configuration, such as increasing thread pools, without correlating these changes to specific observed performance degradations within the Forms applications. Option C. Immediately initiate a comprehensive tuning of the Oracle database, focusing on indexing strategies and buffer cache optimization, without specific analysis of the Forms application's code or execution flow. Option D. Implement client-side performance enhancements for the Oracle Forms client, such as increasing browser cache settings, assuming the bottleneck is primarily in the presentation layer. The correct answer is A. Analyze Oracle Forms server logs, trace specific form execution paths, and examine the generated SQL statements executed against the database to identify inefficient PL/SQL code, SQL queries, or forms object configurations. Explanation. Scenario analysis. This scenario presents a common challenge in application development where performance bottlenecks are identified. The professional challenge lies in accurately diagnosing the root cause of the performance issue within the Oracle Forms application and its underlying components, and then selecting the most effective and compliant resolution strategy. Misdiagnosis can lead to wasted development effort, continued performance degradation, and potential noncompliance with application performance standards, which, while not explicitly a regulatory mandate in the context of 1Z0-151, are critical for business operations and user satisfaction. The need for a structured, data-driven approach is paramount. Correct approach analysis. The correct approach involves a systematic investigation of the Forms application's architecture and runtime behavior. This includes analyzing the Forms server logs, tracing the execution of problematic forms, and examining the database interaction. Identifying specific PL/SQL code, SQL queries, or forms object configurations that are contributing to the performance degradation is key. Implementing targeted optimizations, such as rewriting inefficient SQL, optimizing PL/SQL logic, or adjusting forms configuration parameters based on this analysis, represents best professional practice. This data-driven, diagnostic approach ensures that solutions address the actual problem, leading to efficient and effective performance improvements. This aligns with general IT best practices for problem-solving and application maintenance. Incorrect approaches analysis. One incorrect approach is to immediately assume the issue is solely with the database and begin broad, unanalyzed database tuning efforts. This fails to consider the Forms application's own logic and configuration as potential culprits. It's an inefficient use of resources and may not resolve the form-specific performance issues. Another incorrect approach is to blindly apply generic performance tuning tips without understanding the specific context of the application's usage patterns and code. This can lead to unintended consequences or simply fail to address the actual bottleneck. A third incorrect approach is to focus solely on client-side rendering issues without investigating server-side processing, which is often the primary source of performance problems in Forms applications. This ignores the core execution environment. Professional reasoning. Professionals should approach performance issues with a structured methodology. This involves 1. Problem definition. Clearly articulate the observed performance issue. 2. Data gathering. Collect relevant logs, performance metrics, and user feedback. 3. Hypothesis generation. Formulate potential causes based on the gathered data. 4. Testing and validation. Systematically test hypotheses by analyzing specific components, forms, code, database queries, server configuration. 5. Solution implementation. Apply targeted fixes based on validated hypotheses. 6. Verification. Measure performance after implementing the solution to confirm improvement. This iterative process ensures that solutions are effective, efficient, and based on a thorough understanding of the application's behavior. Question 14. The assessment process reveals that critical form module in an Oracle Fusion Middleware 11G application requires specific fields to be enabled or disabled based on the value entered in a preceding field and the current status of the record being edited. For instance, if a status field is set to approved, subsequent approval date and approver name fields should become enabled. Conversely, if the status field is changed to rejected, these fields should be disabled, and a rejection reason field should become enabled. The development team is considering different strategies to implement this dynamic UI behavior. Option A. Utilize a combination of when any W item instance and post change triggers on the status item to conditionally set the enabled property of the relevant form items, ensuring that the logic is localized to the form module. Option B. Create a separate database package that contains procedures to determine the enablement state of the form items based on the status value and call these procedures from the form module. Option C. Implement the logic within when validate item or post change triggers associated with the status item, using PL/SQL to directly set the enabled property of the approval date, approver name, and rejection reason items. Option D. Embed JavaScript code within the form module to handle the UI updates, assuming that the Oracle Forms application is deployed in a web environment. The correct answer is C. Implement the logic within when validate item or post change triggers associated with the status item, using PL/SQL to directly set the enabled property of the approval date, approver name, and rejection reason items. Explanation. The assessment process reveals a common challenge in application development, managing user interface elements and their behavior across different states of an application. In Oracle Forms, this often translates to controlling when and how fields, buttons, or other visual components are enabled or disabled based on business logic or data entry requirements. The professional challenge lies in implementing this control efficiently, maintainably, and without introducing unintended side effects, ensuring the application adheres to expected user workflows and data integrity rules. The correct approach leverages Oracle Forms' built-in triggers and properties to declaratively manage component states. By using triggers like when new item instance, when validate item, or post change, developers can dynamically alter the enabled property of form items based on the current context, such as the value of another item, the record status, new, existing, deleted, or user roles. This method is best professional practice because it aligns with the event-driven architecture of Oracle Forms, promotes code reusability within the form module, and makes the logic transparent and easier to debug by keeping it close to the UI elements it affects. It adheres to the principle of least privilege and ensures a predictable user experience, which is implicitly expected by users and business stakeholders. An incorrect approach would involve attempting to manage component enablement solely through PL/SQL code embedded within complex, non-standard triggers or procedures that are not directly tied to the UI element's lifecycle. This can lead to scattered logic, making it difficult to track dependencies and understand why a component is enabled or disabled. It also increases the risk of race conditions or missed updates if not all relevant events are captured. Another incorrect approach might be to hardcode enablement logic directly into database triggers or procedures that are called from the form. This violates the separation of concerns principle, making the form's behavior dependent on backend logic that is not readily visible or manageable within the form's development environment. This can also lead to performance issues and makes the form less portable if the backend logic changes. Professionals should employ a decision-making framework that prioritizes using the most appropriate and declarative features of the development tool. When faced with controlling UI element states, the first consideration should be whether Oracle Forms' built-in triggers and item properties can achieve the desired outcome. If complex logic is required, it should be encapsulated within well-defined PL/SQL procedures called from appropriate form triggers, ensuring clear documentation and adherence to naming conventions. The goal is to create applications that are robust, maintainable, and intuitive for the end user. Question 15. Analysis of a scenario where an Oracle Forms application needs to ensure that a specific numeric field representing a product's stock quantity never stores a negative value. The application is part of a larger system where data might also be updated via direct SQL queries. The development team is considering different approaches to enforce this business rule. Option A. Rely on user training and manual checks to ensure that negative stock quantities are not entered into the system. Option B. Implement a database-level check constraint on the stock quantity column to prevent negative values from being inserted or updated. Option C. Implement a when-validate-item trigger in the Oracle form to check if the entered stock quantity is negative and display an error message. Option D. Implement a when-any-wrecord instance trigger in the Oracle form to iterate through all items and check for negative stock quantities. Correct answer is B. Implement a database-level check constraint on the stock quantity column to prevent negative values from being inserted or updated. Explanation. Scenario analysis. This scenario presents a common challenge in application development, ensuring data integrity and user experience while adhering to system constraints. The developer must balance the need for accurate data capture with the practical limitations of the Oracle Forms environment and the underlying database. The professional challenge lies in identifying the most robust and maintainable solution that minimizes potential data corruption and avoids user frustration, all within the context of the 1Z0-151 Oracle Fusion Middleware 11G. Build applications with Oracle Forms Framework. Correct approach analysis. Implementing a database-level constraint, e.g., a check constraint or a trigger, is the best professional practice. This approach enforces data validation at the most fundamental level, the database itself. This ensures that no invalid data can ever be committed, regardless of how the data is entered, e.g., through the Oracle form, direct SQL, or another application. This aligns with the principle of fail-fast and promotes data consistency across the entire system. For the 1Z0-151 exam, this demonstrates an understanding of leveraging the database's inherent capabilities for robust data management, a key aspect of building reliable applications. Incorrect approach is analysis, relying solely on client-side validation within Oracle forms, e.g., using when-validate-item triggers, is professionally unacceptable because it is easily bypassed. Users can disable client-side scripts, or data can be entered through other means not involving the form. This creates a significant risk of data corruption and inconsistency. Ethically, it fails to provide a reliable safeguard for the data. Implementing complex validation logic within the Oracle Forms application without a corresponding database-level constraint is also professionally weak. While it might catch some invalid data, it duplicates effort and is less secure than database-level enforcement. If the business logic for validation changes, it would need to be updated in multiple places, the form and potentially other applications, increasing the risk of errors and maintenance overhead. This approach is less robust and harder to manage, deviating from best practices for application architecture. Professional reasoning. Professionals should approach data validation by prioritizing the most secure and reliable enforcement points. The database is the ultimate source of truth, and therefore, database-level constraints and triggers should be the primary mechanism for enforcing data integrity. Application-level validation, like that in Oracle Forms, should be used to enhance user experience by providing immediate feedback, but it should never be the sole means of validation. A layered approach, with database-level enforcement as the foundation, ensures data accuracy and system stability. When faced with such a decision, a developer should consider: 1. Where is the most critical point to enforce this rule? 2. What are the potential bypasses for each validation method? 3. Which method offers the best long-term maintainability and scalability? Question 16. Benchmark analysis indicates that a team developing an Oracle Forms application is planning to introduce significant database schema modifications to support new application features. The team is considering several deployment strategies for these changes to the production environment. Which strategy best balances the need for timely feature delivery with the imperative to maintain data integrity and application stability? Option A. Implement the schema changes in the development environment and then schedule them for deployment during the next major application release cycle, which is 6 months away. Option B. Deploy the schema changes directly to the production database immediately after they are finalized in the development environment, assuming that thorough unit testing and development is sufficient. Option C. Develop a comprehensive deployment plan that includes thorough testing of the schema changes in a staging environment mirroring production, followed by a phased rollout to production with a documented rollback procedure. Option D. Inform the end users about the upcoming schema changes and ask them to back up their data before the changes are applied to the production database. The correct answer is B. Deploy the schema changes directly to the production database immediately after they are finalized in the development environment, assuming that thorough unit testing and development is sufficient. Explanation. This scenario presents a common challenge in application development, managing the lifecycle of database objects and ensuring data integrity across different environments. The professional challenge lies in balancing the need for rapid development and testing with the imperative to maintain a stable and reliable production environment. Developers must consider the impact of schema changes on existing data and the potential for data corruption or application downtime. Careful judgment is required to select a deployment strategy that minimizes risk while maximizing efficiency. The correct approach, which involves a phased rollout with rollback capabilities and thorough testing in a staging environment that mirrors production, represents best professional practice. This aligns with principles of robust software engineering and risk management. Specifically, it adheres to the implicit guidelines of ensuring application stability and data integrity, which are paramount in any professional development context, especially when dealing with production systems. The emphasis on testing in a staging environment before production deployment is a critical step in preventing unforeseen issues and ensuring that the application functions as expected with the new schema. The rollback plan is essential for mitigating the impact of any unexpected problems that might arise during or after the deployment. An incorrect approach that involves directly deploying schema changes to production without prior testing in a staging environment is professionally unacceptable. This bypasses essential quality assurance steps, significantly increasing the risk of data corruption, application errors, and extended downtime. Such an action demonstrates a disregard for data integrity and user impact, violating fundamental professional responsibilities. Another incorrect approach, which is to delay all schema changes until a major release cycle, can also be professionally problematic. While it consolidates changes, it can lead to significant technical debt and make future deployments more complex and risky due to the accumulation of numerous changes. This can also hinder the timely delivery of new features that depend on these schema modifications, impacting business agility. A third incorrect approach, which is to only implement schema changes in development and assume they will work in production, is a severe lapse in professional judgment. This ignores the critical differences between development and production environments, including data volume, user load, and security configurations, all of which can expose issues not apparent during development. This approach directly jeopardizes the stability and reliability of the production system. The professional reasoning process for similar situations should involve a structured risk assessment. This includes identifying potential impacts of the proposed changes, evaluating the likelihood and severity of those impacts, and developing mitigation strategies. A phased deployment, comprehensive testing in representative environments, and a well-defined rollback plan are key components of a responsible deployment strategy. Developers should always prioritize data integrity and application stability, especially when interacting with production systems. Question 17. Process analysis reveals that users are experiencing significant delays when interacting with a critical Oracle Forms 11G application, particularly during data retrieval operations. The application's performance has degraded over the past few weeks, impacting productivity. Without a clear understanding of the bottleneck, the development team is considering several immediate actions to address the perceived slowness. Which of the following approaches represents the most professional and effective method for diagnosing and resolving the performance issue? Option A. Systematically enable forms tracing and analyze the generated trace files to identify specific PL/SQL blocks, database calls, or module execution paths that are contributing to the delays. Option B. Deploy a more powerful application server to handle the increased load, without first profiling the existing application's resource utilization. Option C. Immediately increase the maximum number of database connections available to the forms server, assuming connection pooling is the cause of the slowdown. Option D. Rewrite all PL/SQL procedures involved in data retrieval to use different syntax, hoping to find a more efficient implementation. Correct answer is A. Systematically enable forms tracing and analyze the generated trace files to identify specific PL/SQL blocks, database calls, or module execution paths that are contributing to the delays. Explanation. Scenario analysis. This scenario presents a common challenge in application development where performance bottlenecks can impact user experience and system stability. The professional challenge lies in accurately diagnosing the root cause of the performance degradation without resorting to premature or incorrect solutions. Misdiagnosing the issue can lead to wasted development effort, increased costs, and a failure to address the actual problem, potentially violating service-level agreements or internal performance standards. The need for careful judgment arises from the interconnectedness of various application components and the potential for subtle issues to manifest as significant performance problems. Correct approach analysis. The correct approach involves a systematic and data-driven investigation. Utilizing Oracle Forms built-in tracing and profiling tools is paramount. These tools provide granular insights into the execution of forms modules, database interactions, and PL/SQL code. By analyzing the generated trace files, developers can pinpoint specific areas of the application that are consuming excessive resources, such as slow database queries, inefficient PL/SQL logic, or excessive network traffic. This methodical approach ensures that solutions are targeted, effective, and address the actual performance bottleneck, aligning with best practices for application maintenance and optimization. This adheres to the implicit professional obligation to deliver functional and performant applications, as per the exam's focus on building applications. Incorrect approach is analysis. Implementing broad, unverified optimizations without diagnostic data is a significant professional failure. For instance, blindly increasing database connection pool sizes without evidence of connection exhaustion is an inefficient use of resources and might not solve the problem. Similarly, rewriting large sections of PL/SQL code based on a hunch, rather than profiling, risks introducing new bugs and further degrading performance. These approaches lack a foundation in evidence and can lead to wasted effort and a failure to meet performance objectives, which is a breach of professional responsibility to deliver a well-functioning application. Professional reasoning. Professionals should adopt a structured problem-solving methodology. This begins with clearly defining the observed problem, e.g., slow response times. Next, gather diagnostic data using appropriate tools, forms tracing, SQL tracing, performance monitoring. Analyze this data to identify the root cause. Once the cause is identified, develop and implement a targeted solution. Finally, retest and monitor the application to confirm the issue is resolved and no new problems have been introduced. This iterative, data-driven process ensures efficient and effective problem resolution. Question 18. Research into the most effective and secure method for implementing role-based access control within an Oracle Fusion Middleware 11G Oracle Forms application, specifically concerning the visibility and enablement of specific menu items and form elements for different user groups. Option A. Implement custom PL/SQL code within form triggers to dynamically check user roles and grant or deny access to specific functionalities. Option B. Rely exclusively on database-level grants and privileges to restrict user access to data, assuming the form's application will inherently reflect these restrictions. Option C. Embed user role information directly within the form's data blocks, allowing the application to infer user permissions from the data itself. Option D. Utilize Oracle Forms built-in security features to conditionally display or enable form elements and menu items based on the authenticated user's assigned roles. The correct answer is D. Utilize Oracle Forms built-in security features to conditionally display or enable form elements and menu items based on the authenticated user's assigned roles. Explanation. The scenario presents a common challenge in application development, managing user interface elements and their behavior across different user roles within an Oracle Forms application. The professional challenge lies in ensuring that the application adheres to security principles and provides an appropriate user experience without compromising data integrity or exposing sensitive functionalities to unauthorized users. This requires a deep understanding of Oracle Forms' built-in security features and best practices for role-based access control. The correct approach leverages Oracle Forms' native security mechanisms, specifically the ability to control object visibility and functionality based on the logged-in user's role. By associating specific menu items, buttons, or even entire blocks with particular user roles, developers can ensure that only authorized users can access or interact with sensitive data or functions. This aligns with the principle of least privilege, a fundamental security concept that dictates users should only have the permissions necessary to perform their job functions. This method is robust, maintainable, and directly supported by the Oracle Forms architecture, making it the most professional and secure solution. An incorrect approach would be to hardcode security logic directly within triggers or PL/SQL code that checks user credentials or roles at the point of interaction. This is problematic because it creates a brittle system that is difficult to update and prone to errors. If a user's role changes or a new role is introduced, developers would have to manually modify code across multiple triggers, increasing the risk of introducing security vulnerabilities or functional bugs. Furthermore, this approach often leads to code duplication and makes auditing security configurations cumbersome. It also bypasses the declarative security features provided by Oracle Forms, which are designed for precisely this purpose. Another incorrect approach might involve relying solely on database-level security to restrict access to data. While database security is crucial, it doesn't address the user interface aspect of controlling what a user asterisk sees asterisk or can asterisk do asterisk within the Forms application itself. A user might be prevented from updating a record at the database level, but if the form still displays the editable fields and allows them to attempt an update, which will then be rejected by the database, it creates a poor user experience and can lead to confusion. The application should proactively guide the user by only presenting them with relevant and accessible options. The professional decision-making process should begin with identifying the security and functional requirements for different user roles. Then, evaluate the available tools and features within Oracle Forms to meet these requirements. Prioritize declarative security features over custom coding for better maintainability and adherence to best practices. Thorough testing with different user roles is essential to validate that access controls are functioning as intended and that the user experience is appropriate for each role. Question 19. The risk matrix shows potential performance degradation and increased resource utilization when retrieving data for an Oracle Forms application. A developer is tasked with building a form that displays customer order history. The underlying database table orders contains over 100 columns, but the form only needs to display the order ID, order date, total amount, and customer name. Which approach best mitigates the identified risks while adhering to efficient application development practices? Option A. Implement a complex, multi-level subquery within the Forms block to dynamically fetch only the required columns based on user input. Option B. Use a select asterisk statement in the Forms block properties to retrieve all data from the orders table and rely on the Oracle database's default query optimization. Option C. Fetch all columns from the orders table into the Forms block and use client-side PL/SQL to filter and display only the required fields. Option D. Create a database view that selects only the necessary columns, order ID, order date, total amount, customer name, from the orders table and base the form block on this view. The correct answer is C. Fetch all columns from the orders table into the Forms block and use client-side PL/SQL to filter and display only the required fields. Explanation. Scenario analysis. This scenario presents a common challenge in application development, balancing the need for efficient data retrieval with the potential for performance degradation and security vulnerabilities. Developers must consider how data is accessed and manipulated within Oracle Forms applications, especially when dealing with large datasets or complex queries. The risk matrix highlights potential issues related to performance bottlenecks, increased resource consumption, and the possibility of exposing sensitive data if not handled correctly. The professional challenge lies in selecting the most appropriate method for data retrieval that aligns with best practices for Oracle Forms development and adheres to any implicit or explicit performance and security guidelines. Correct approach analysis. The correct approach involves leveraging Oracle Forms' built-in capabilities for efficient data retrieval, such as using database triggers or stored procedures to pre-process or aggregate data before it's fetched by the form. This method is considered best professional practice because it pushes data processing logic closer to the database, where it can be optimized by the Oracle database engine. Stored procedures and triggers can be highly efficient, especially when dealing with complex calculations or filtering large volumes of data. This reduces the amount of data transferred between the database and the application tier, leading to faster form loading times and a more responsive user experience. Furthermore, encapsulating logic within the database can improve maintainability and consistency across different applications accessing the same data. From a regulatory perspective, while the 1Z0-151 exam doesn't specify external regulations, best practices in application development often align with principles of data integrity and security, which are implicitly supported by efficient and controlled data access. Incorrect approaches analysis. One incorrect approach involves fetching all columns from a large table into the forms block, even if only a subset of those columns is ever displayed or used by the user. This is professionally unacceptable because it leads to unnecessary data transfer, increased memory usage on both the client and server, and can significantly degrade performance, especially on slower networks or less powerful hardware. It violates the principle of least privilege for data access, potentially exposing sensitive information that the user doesn't need to see. Another incorrect approach is to rely solely on client-side PL/SQL within the form to perform complex data filtering or aggregation after fetching a large dataset. This is inefficient and can lead to poor performance because the processing is done on the client, which is typically less powerful than the database server. It also increases network traffic and can make the application appear sluggish. This approach can also be more difficult to debug and maintain compared to server-side logic. A further incorrect approach might be to use inefficient SQL queries within the form's block properties, such as using select asterisk on very wide tables or employing subqueries that are not optimized. This directly impacts performance by forcing the database to retrieve more data than necessary and potentially execute complex, unoptimized operations. It can also lead to locking issues and increased database load, affecting other applications and users. Professional reasoning. Professionals should approach data retrieval in Oracle Forms by first understanding the data requirements of the form and the user. They should then consider the most efficient place to perform data processing, typically the database server for complex operations. Evaluating the trade-offs between performance, maintainability, and security is crucial. When designing forms, developers should aim to retrieve only the data that is necessary for the current user interaction. This involves careful SQL query design, utilizing stored procedures or database triggers for complex logic, and avoiding fetching unnecessary columns or rows. Regular performance testing and profiling are essential to identify and address potential bottlenecks early in the development lifecycle. Question 20. Stakeholder feedback indicates that users are experiencing significant delays when navigating through records in a critical Oracle Forms application, particularly when displaying a large dataset. The development team needs to identify the most effective strategy to diagnose and resolve this performance bottleneck. Option A. Increase the fetch size of records per block in the Forms module without investigating the underlying query. Option B. Write the data retrieval logic using complex PL/SQL procedures within the Forms module to bypass standard SQL. Option C. Analyze the SQL queries where clause and examine its execution plan to identify inefficiencies in data retrieval. Option D. Immediately implement client-side JavaScript optimizations to speed up the rendering of fetched records. Correct answer is C. Analyze the SQL queries where clause and examine its execution plan to identify inefficiencies in data retrieval. Explanation. Scenario analysis. This scenario presents a common challenge in application development where performance bottlenecks can impact user experience and system stability. The professional challenge lies in accurately diagnosing the root cause of the performance degradation within an Oracle Forms application, specifically when dealing with data retrieval and display. Without a systematic approach, developers might resort to superficial fixes that don't address the underlying issue, leading to recurring problems and wasted development effort. The need for careful judgment arises from the potential for misinterpreting symptoms, leading to incorrect architectural or coding decisions. Correct approach analysis. The correct approach involves a methodical investigation of the data retrieval process, focusing on the efficiency of SQL queries executed by Oracle forms. This aligns with best professional practices for application performance tuning. Specifically, examining the where clause of the select statement and analyzing the execution plan of the SQL query are critical steps. A well-formed where clause, utilizing appropriate indexes, ensures that the database retrieves only the necessary data, minimizing I/O operations and processing time. Analyzing the execution plan reveals how the database optimizer intends to access the data, highlighting potential inefficiencies such as full table scans or suboptimal join orders. This deep dive into the SQL execution is paramount for identifying and resolving performance issues at their source, ensuring the application remains responsive and scalable. This approach is ethically sound as it prioritizes delivering a functional and efficient product to end users. Incorrect approaches analysis. One incorrect approach is to immediately focus on client-side rendering optimizations without first verifying the efficiency of the data retrieval. This is a regulatory failure, because it neglects the fundamental principle of efficient data handling, which is often implicitly or explicitly covered in application development standards and best practices that aim to ensure system integrity and performance. Another incorrect approach is to assume that increasing the number of records fetched per block is a universal solution. This can lead to performance degradation if the underlying query is inefficient, as more data will be transferred and processed unnecessarily, violating principles of resource optimization and potentially impacting system stability. A third incorrect approach is to bypass the database's query optimization by hard-coding complex PL/SQL logic within the forms module to manipulate data. This not only makes the code harder to maintain and debug, but also ignores the highly optimized SQL engine of the database, which is designed to handle data retrieval and manipulation far more efficiently. This can be considered an ethical failure as it represents a suboptimal use of resources and a disregard for established database best practices. Professional reasoning. Professionals should adopt a systematic, data-driven approach to performance tuning. This involves 1. Identifying the specific symptoms of performance degradation. 2. Isolating the problematic component or operation, e.g., data retrieval display logic. 3. Utilizing diagnostic tools, e.g., SQL trace execution plan analysis to understand the underlying behavior. 4. Formulating hypotheses about the root cause. 5. Testing these hypotheses with targeted changes. 6. Measuring the impact of changes to confirm improvements. This structured process ensures that solutions are effective, sustainable, and address the actual cause of the problem rather than just its symptoms.